Everyone, today we'll be discussing our portal frame group project that has been prepared in Revit and Spacegass. We've developed a preliminary structural design and full CAD model of a steel portal frame building in Autodesk Revit 2025. This design responds to a client brief specifying the rafter design, overall dimensions, span and eaves height, and was prepared to align with the Australian building standards. This file was then imported into Spacegass in order to analyze different loads, particularly that of the Wollongong area. So here we have our preliminary design. Our project-specific parameters are the following. So we've got a rafter load of 12 kilonewtons, a building length of 36 meters, a total span of 28 meters, eaves height of 10 meters, and we also have a roof pitch of 6 degrees.
Our portal frame was designed to meet the client brief and comply with Australian building standards. We confirmed geometry and design parameters, then selected suitable column and rafter sizes from the One Steel catalogue. C-section, girts, and purlins were chosen from light sort ZC's tables for stiffness and fixity. A plane frame model was built and tested under Australian New Zealand Standard Code 1170 load cases to verify strength and deflection performance. Constructability guided our decisions. Bay modules and connections were standardised, transport limits respected, and openings aligned to maintain girt continuity. All members and cladding were all modelled in Revit, with design check documented for quality assurance. Collaboration through shared documents ensured clear communication and consistent revisions across the team. The concrete slab is 400mm thick and measures 36.5 by 28.5 metres, allowing for a wall offset. The main frame uses universal columns 610 by 229 by 101, spaced 6 metres apart, while lighter universal columns 305 by 305 by 97 columns support the mezzanine, as these carry smaller loads.
The purlins used for the portal frame are light gauge steel Z-section purlins, and the maximum length that each Z-section is manufactured to is 12,000 millimeters. The purlins sit above the rafter beams and have a separation of 2,925 millimeters between them. And as for the roofing, the roof sheeting implemented in the portal frame warehouse is Cliplock 700 and has a thickness of 48 millimeters. The roof offset is in line with the slab edge, giving an overhang of 250 millimeters from the wall cladding, and the roof sheeting sits flush on top of the Z-section purlins.
The portal frame's design also consists of cleats, which were used to connect other design pieces such as girts and purlins to the portal frame. These were used to improve their long-term sustainability and stability, helping them to stay in place now and in the future. There are also several innovative components included in the design. The first of which is the skylight to let in more natural light for both practical and visual purposes within the design. This may help in the future eliminate some of the need of unnatural lighting within the structure. Another of these components is the reinforcing columns, designed to be built on either side of the apex of the roof to help ensure the long-term stability of the structure. This was our final design in Revit. And this is a screenshot of our final design in Spacegass.
Due to the location being Wollongong for the portal frame's placement, it was important to consider the effects of the higher amount of wind than some other possible locations. This is due to its close proximity to the ocean and relative climate. Due to this factor, it was ensured within the design that the wind would not be a problem, and it was reinforced well to compensate for this factor. The particular loads were tested within Spacegass using the wind loads function, utilizing Wollongong's A2 wind region. Our steel portal frame design offers a wide, column-free interior for flexible racking and vehicle movement. Standardized repeatable bays reduce fabrication time, site labor, and waste, keeping costs predictable. Short fabricated steel and simple connections allow rapid assembly and early handover. The frame can be easily expanded or modified, and with corrosion protection, it ensures long service life and minimal maintenance.